Guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mask code at this side. So today the question is search in a row column sorted matrix. The question is actually very simple. The question says that you haven't given a matrix, right? And it is row column sorted. What do I mean by row column sorted is that each row is sorted. Each row is sorted. This is the first point. And second point is each column is sorted. Each row is sorted, that you can see. This is a sorted row. This is again a sorted row. This is again a sorted row. And similarly, each column is sorted. This is a sorted column, sorted column, sorted column. Right? 38 less than 54 less than 69. 30 less than 52 less than 60. 3 less than 20 less than 35. Similarly, 3 less than 30 less than 38. 20 less than 52 less than 54. 35 less than 60 less than 69. Okay. Now, in this matrix, you need to find x equals to 20. If this x equal to 20 is present, return true, else return false. Else return false. Obviously, we are able to spot 20 here, so our answer is going to be true. But how we will reach this, right? How will we reach this? Okay. So I don't like to mention the brute force approach. Of course, the brute force approach is traverse the whole matrix using two nested loops, whole matrix, right? If you find the value, then return true. At the end of the loop, if you don't find a value, return false, right? It is taking O of n m time, considering the order of the matrices n into m, right? O of n m time, and space is O of 1, and this is time. Okay, this is the naive approach. It's the brute force approach, but we are not here for the brute force approach. We are here for the optimized approach. So what is the optimized approach? Now, sorted, right, and search. Again, two words: search, sorted, and search, or I can say find. Whenever these two occurs, I'll say that this question can be solved by linear search, which we are doing for the brute force, right? Linear search is possible here, but but binary search is obviously our go-to approach. That we, whenever these two words are there, we need to think about binary search. We need to think about. It might not be possible in every case that we are able to implement binary search, but we should think about whenever these two words are there. This is a clear indication of binary search, right? Mostly, 19% of the cases. How will we solve them? How will we solve them? I know that each row, smallest elements lie on the left side. Each row, largest element lie on the right side. Okay. Can I use that fact? Can I use that fact? Okay. So, what do I say? Lowest elements, largest elements. Right? So, for the given matrix, I can say that if 20 lies between 3 and 38, then the row 1 has a potential to carry 20. Row 1 can carry 20. 20 lies between 20 and 54. It also has a potential. 20 does not lie between 35 and 10. It does not have a potential, right? So still I have to use O of, like I am using O of 2 into log m time complexity, right? And suppose the matrix is set such that only one row contains 20, but all the rows contain, what do I mean to say? All the row contain the range of 20, that is 3, 38, 20, 54, and suppose instead of 35 it was 569 here. Then this also was a contender. So it will be O of n log m in that case. O of n log m. How O of n log m? I'm telling that for I equals to 0 up till n minus 1. So if mat of I0 is less than equals to x and mat of I m minus 1 is greater than equals to x. That means this row can carry x. Binary search on that particular row, on row I, right? Alright. So O of n log m. I don't want to mention this case also. Obviously, this is a better approach, but I don't want to mention this. I want to go even down. What do I want to do is, let us say that I am standing on this row. That is, I'm standing on row 0. And I'm standing on column number m minus 1. In this case, that is equals to 2. Last column, let me write it down, last column, first row. That is, in a matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm standing here, right? I compare this element to x. Three conditions can occur. Let us say this element is y, and we have x equal to 20, right? We're following the above matrix only, right? I don't like to copy it down below only, right? Okay, so three cases are y equals to x, y greater than x, and y smaller than x, right? If this condition arises, that is, we are standing at an element which is equal to x, we can return true. We can return true. Obviously, we found the element. Now, the two conditions are y is greater than x or y is less than x. Y is greater than x. That means this element is actually greater than we are expecting. Is actually greater than we are expecting. Now, tell me, if we are trying to find 20, and if this element is 35, right? Now we know that this element is smaller, this element is larger. The element to the left is smaller, the element to the right below is larger. Where should we go? Obviously, we need to go to smaller because 35 is greater than 20, so we need to go smaller. That is column minus minus. That is, this last column will become last minus 1, right? Okay. Similarly, if this y is greater than 20, is less than 20, that is, if this y was 15, then you need to go to downwards, that is row plus plus. As simple as that. This is not complicated at all. If you are standing at the equal element, return true. If you are standing at greater element, decrease your column because that helps in removing. Otherwise, if that is less, row plus plus, right? Now, if we try for this particular case, let me create some space here. Yeah, let me create some space. Let me create some space, right? Yeah. Okay. So currently we are standing at this element. We have element in hand 20. We need to find 20. Standing at 38. 38 is greater than 20. Come here. 30. 30 is still greater than 20. Come here. 3 is less than 20. That means we need to go down 20. As soon as we find 20, we return to. Now the question arises, what is your time complexity? What is the time complexity? Now you will say that because it is a binary source, so it will be O of log. But what will be O of log? What will I write in the bracket? N or M? Some of you will say M, like multiple of NM. But I will say no. Why? If you see that I am only going towards this direction or this direction, I'm not going upwards or rightwards. These directions are prohibited. I'm only going towards left or down. That means in the left direction I can maximum have O of M, and O in the right downward direction O of N can be the maximum. That means if we sum them up, so it will be O of N plus N. Thus that, like what I'm trying to say is, if this element 20 instead of 20, it would be having 35. So what would have happened? What would have happened? Let me write it down. Let me use another pen. Yeah, we would have standing at 38. We would be standing at 38. 38 is greater than 35. Moved here. 30 is still lower than 35, move here. 52 is greater than 35, move here. 20 is less than 35, move here. Now, as soon as you move here, you return true. So if you see one operation, second operation, third operation, fourth operation, fifth operation. So O of 5, which is still less than O of n plus m. So our time complexity is O of n plus m, which is a linear time complexity. O of linear time complexity. You would say that this is also linear. No, this is n into m. Suppose the matrix order is n into n, so it will be O of n square. It is a square time complexity, whereas we have linear time complexity. So I hope you are getting my point, right? Space used here is also O of 1, that is constant space. So let us move to the code. I hope this algorithm is clear to you. That's why the question is also marked as easy. So let us try to write the code down. First of all, let me take the sizes. So number of rows equals to mat dot size, and number of columns equals to mat 0 dot size. That is the elements in first row. Now we are standing from the first row, that is int I equal to 0. This is I is for my row, and starting from column m minus 1, that is the last column. While I is less than n, that is the last row is overcome. When I equal to n, that means that we are not able to find the matrix element in the matrix, or j is greater than equal to 0. What we will do? So if mat ij equal to x, return true. Otherwise, if mat ij is greater than x. If it is greater than x, then we need to like reduce my ij. That means j minus minus. Else I plus plus. Return false otherwise. Right? Let us try to compile and run it. Hope it will work fine. Working fine for the sample test case. Let us try it for the submit as well. Working, and getting accepted. So thank you for watching. Hope you liked it. Please make sure to like and subscribe to the channel. Thank you. Have a nice day.